Right now we are on the Leet code 130 surrounded region, so we want to convert all of the O that is surrounded by X. So this O is just kind of like aligned surrounded by X, so then X, and here we convert that into an X. But this O on the bottom it has nothing, so we will not convert that into X. It will become value of O. Here I already have the same board as the input. This is the unit test and this is the expectation. And when I run it, it's already true because I already did it. This is for later. Don't look at it first. And we will put a pointer in here at the beginning, since we have the helper method of boundary DFS. We will put also a breakpoint in here. Let's see what do we have. Right now we will have a board of 4 times 4. We have the board length and board index 0 dot length, both of them equal 4 because this is the row and the index 0 is the column. How you read that? So board.length is how many curly brackets that we have in here. This is array of an array. Inside the first array, there are another 4 array. From each 4 array, they have 4 elements. You see the contrast in here. This is the same board.length is 4, but if you put that into board of, if you use this, whatever, variable, or like constant, I'm not that good with that. Board index 1.length is equal 5 because at this array we have 5 elements. 1, 2, 3, 4, 5. That's pretty much. Look for extra resources if you get confused because I'm not going to explain it in here. So right now we set up for the row, which is like board.length, and columns board at index 0. Can be index 0, 1, 2, 3. It doesn't really matter because all of them, as long as inside the index, it will also return 4. It also count as 4. So what do we do right now? We have 2 iterations. Iteration for the I in the row and J in the column. In the row, we are going to check the edges in here. Is there any O in here or not? And at the column, we are going to check the one in here. So right now, let's check it. I right now is 0. Board of 0, 0. Board of 0, 0. When you look at it, it's like board of I 0, 0 is an X. That's why it's in here. And you can look at the value from the glasses in here is an X. So it is not an O. We will not execute the helper method boundary DFS. We just move forward. Okay, let's look at in here. What happened at this point, which is like board of I 0 at the columns that is like 4 minus 1 3. What happened at the board on the coordinate of like 0 and 3? 0 and 3. Where is that? 0 and 3. That's also an X. We don't do anything. We're moving on. And right now we check for the row index 1, column index 0. It's an X. Nope. And row index 1, column index 3. Row index 1, column index 3 is an X in here. This one, I'll just look at the value in here. Right now, and I is 2. We look at it. See, 2 at the column 0 is an X. That's here. And then also here is an X. And that is shown in this statement. So we can move. Right now at the 3 is an X in here. That is like at the row index 3, column index 0. Row index 3, column index 0. That's an X. And row index 3, column index 3. Row index 3, column index 3. That's also an X. Okay, so we don't find anything in the row iteration. We go to the column iteration. The column iteration will start at the row index 0 and column index 0. That's also an X. What happened at the row index 3, right? Because row is 4 minus 1, 3. row index 3, column index 0. That's also an X. Okay. Next, J is 1. What happened at the row index 0 and column index 1? That's an X. What happened at the row index 3, column index 1? That's an O. When it's an O, we go to helper method, boundary DFS, boundary DFS that take argument board for the row minus 1, that's for the I is 3, and J is 1. So in here, I is 3, J is 1. Right. This is the boundaries check. If I greater than board.length minus 1, I greater than board.length minus 1. So board.length is row in here. Does I is greater than 3 in here? It should not be happen. Let's say it happened and then become true. When true, we don't care something outside of the board. For the row perspective, this is what it says. And then, so in here, does I less than 0? So I 0 in here. This is like, does our point is in here or not? It's not, because it's outside of the box. So it's also false. We continue. Does J greater than board of index 0 dot length? So it's like the board is like next here. It's not next here because it's inside the board. This is the boundary check. And J less than 0 is the boundary check to the left, because any kind of, if J is minus 1, it should be in here, which is like not going to happen. All of them are false. That's why we can continue to the next statement. So at our coordinate, I would say coordinate of the board index I, row index 3, and the column index 1, which is like in here, and you can see also the value in here, that's an O, we convert that into a star. Okay, cool. And then we check for the one that is above. So what does it mean right now? Does I greater than 0? So we go to this statement, it's I greater than 0, which means like if it is not greater than 0, it will be above here, which is like it's outside of the board, and we will not check it. So I greater than 0, which is like yes. And then we're going to check, does what happened to the point above us? So this statement meaning above us, because right now I is 3, we are at the row index 3 and the column index 1. We want to check the row index 2 in here. Is this a no? It's not. So we just move on. Okay, right now we check at the bottom. Is there any value at the bottom of our coordinate right now? No, because I less than board.length minus 1. I is 3 less than 4 minus 1. 3 is not less than 3 is the same. So it falls, which means that there is nothing on the bottom of our coordinate. Cool. So right now, does J greater than 0? Yes, so there is something to our left, because this is J minus 1, we go to the left. Is there something at our left? Yes. Is that an O? No. Okay, we don't do anything. So in here, does J go outside of the boundaries? J should be less than the boundaries in here. If it is not true, it will be outside of the boundaries. And does the value to the right of us, right in here, which is like this value, equal to O? It's not equal to O. So we just move on. And that is the end of the helper method. We were previously at the 3, 1, right? And that is 3 is the I. That's the end of the that's the end of the one in here. And right now the iteration J will add into 2. Okay, cool. So right now we check for the board index 0, column index 2, which in here, nope. Then we check also here, row index 3, column index 2 is not an O. Okay, what happened at the column index 3? here at the row 0, column index 3 is also an X. And then here, row index 3, column index 0, that's also an X. So we done checking for our boundaries. And in here, there should not be any O in these boundaries or edges. There should not be O because we already convert that into star. If there's an O in here, it will be converted into a star. I should come closer to the mic. So right now, we just iterate to the row and column. It will start from 0, 0, 0, 0 from here, and goes to 0, 1, 0, 2, 0, 3. What does it do? Do we find 0, O? No. Do we find star? No. So we move to the next iteration. If we find 0, we convert that into X. If we don't, oh my god, it's not 0, it's an O. I repeat. If we find O, we will convert that into X. But if we don't find O, we will check whether it is a star or not. If we find star, we will convert that into O. So that's pretty much code in here. So right now we are at the row index 1 in here. In row index 1, column index 0 is neither O, neither star. We don't do anything. But at the row index 1, column index 1, we have an O that's shown in here. And we will convert that into X. Voila, see right now it's an X. The same at the next one, when j equal 2, the value in here is O, and we convert that into X. Pay attention to this one. And it's become X. So we just move on. Right now we are at the 2, 1, 0, 1, 2, 2, 1 in here. And with the next is 2, 2, and that value is O. So this is O, we convert that into X. Cool. We move on. And then right now we are at the row index 3 of the column 0 is still X. But at the row index 3, column index 1, that is a star. So it meets the statement in here. If it is star, we convert that into O. Voila. And we continue looping until the end of the tree in here. And we finish looping. So we get out of the column loop, we get out of the row loop, and we get out of the function, and we assert the expected board in here with the board that we have, and it's true. So that is how Nick White, he solved this problem. There is an exercise that I made it myself in here, which is like 4 times 8, and if I keep clicking it, I would notice that this will turn into star, this will turn into star, this will turn into star, and that's it. And then we go loop, convert to X, 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 we got it X, 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 and then like we got star in here, and when we add this coordinate, it will convert into star. This also and this also. If you want to try it, yeah, that's it.